Hi, everybody, and welcome. Today we're going to be going through, in our intro to lesson, looking at points, lines, and planes. So that's going to be our goal by the end of this, that you're going to feel comfortable defining and applying those and answering some skill questions about them. What I will say is this is our really first lesson overall for content. A little bit more vocab than we're probably going to see on an average day. Again, a little bit of review here with points, lines, and planes, but another thing you can kind of expect is when we introduce a new chapter, a new unit, you're going to see a lot of vocab is going to come at you first. Then it's going to be followed by more application of that vocab. So just know that if you're someone that likes to do more calculations, there will be areas that you're going to be able to use those calculation skills later. Today's probably not going to be one of those lessons. And also just know that if that's one of your strengths, thinking about vocab and defining words and writing about things, then today's probably going to be a good day for you. So geometry, probably more than any other math course, is going to be a really good mix of both of those things together. All right, so starting off points, lines, and planes. Where in the world do they apply? Why are they important? So I want to start off with this video of my dog, actually. And this is going to tie into the idea of points, lines, and planes. And you'll see why in just a moment. But to start off, I know we probably saw this last week in case you didn't. Solid gold. This is Stella. She deserves her freedom. She doesn't want to be caged in our kitchen. And she's a jumper. She got straight over the top. So she's 60 pounds now. That was right after we adopted her. She was way too thin. She was like 42 pounds, just jumped right over the top, spry on her feet. She was good to go. So after this, actually, we wanted to give her a little bit more room. So we were like, okay, one thing that we could maybe do is we have a nice backyard, put a tie line up there, and she can roam around the backyard. She can have a little bit more space and freedom. So luckily my wife was home when this happened for the first time. She's on her tie line, sees, I think it was like a cat ran in our backyard, and Stella was just gone. Instincts just kicked in. She ran as fast as she could at the cat, reached the end of her tie line, and a nice metal link at the end of it, and literally snapped the metal in half. And I could not believe it when I got home. She just destroyed it. So it's like, all right. Luckily, she came back. She treed the cat, and my wife was able to go over to her, put a leash on her, and bring her back in the house. But that led us to have a conversation about, okay, tie line's probably not going to be a good scenario, a situation to fix this problem. We need something a little bit bigger, a little bit more sturdy, because we don't want to lose her. So we decided on a fence. So thinking about a fence, when we're looking into something like fence design, you have to think about, and I'll draw a little example on the side here, you got to think about height. So if you're drawing like a section of fence like this, if it's too small, not going to work. If it's tall, though, Stella won't be able to jump over top of it. So when we were starting off, we had our little fence design, and the goal of this was to keep Stella in. Okay, so it needed to be high enough. And in this fence design, you would see things like points. You would see things like lines. And all of them would ultimately lay on the same plane. Now, a section of fence isn't a perfect definition of a plane because the plane technically keeps going on forever and forever and forever. But it's a reasonable representation. So points, lines, and planes all go into fence design. When they were doing the schematics, the initial sketch of our fence, that's something that we actually reviewed with them. And I got to see a real life example of points, lines, and planes in its most basic form shown for me there. So that was something that was cool, a direct application. And I wanted to just share the real life example of points, lines, and planes in a way that you can kind of ground your understanding of them. So think about a point as just a location on the fence. Think about a line as maybe like a fence post. And you can think about a plane as like a section of fence, more or less. Not a perfect example, but should be a reasonable approximation. Okay, so we're grounded in reality. We're seeing how this works. Now let's get to the definitions. I am going to talk maybe a little bit more quickly than you can write on these definitions. So I'm going to name this right now. It is okay to pause the video. You can slow down the speed of the video. Either are up to you. Use this at your own pace. Rewatch it if you need to. And if you can keep up with me, that's awesome. But either way, we got some definitions. We're going to put them out here first. So point is our first. And point is a single location without shape or size. All right, so important things to think about this point, no shape or size. I like to think about it as literally just that, a location. you're looking at Google Maps, they drop a pin on the map. You can think about that pin as the location on the map. So I'm going to underline here without shape or size. I'll draw an example of a point. It's literally just a dot, a location. Naming conventions, always capitals. Okay, so we are happy with that. We are unhappy with that. We would lose credit on the quiz if we had something like that drawn in. Okay, so don't do this. Keep it as a capital. All right, a point is simply a location. We draw it as a dot, and it's named by a capital letter. Awesome. All right, let's keep it going. On to our next vocab word. I promise I know how to use things. There it is. Boom. All right, next word here is line. So we're going to define line as a segment that is made up of points. We're going to say a line is made up of points with no thickness or width. So I know that we're used to seeing lines drawn out. Like you draw the line first, you put points on later. If we actually want to break it down to the complete basics of a line, it actually starts off as a whole bunch of points. And a line is just, if we get so small and small and small until we get together, that's how a line is actually made. So we have a bunch of points on a line. A second thing, a line extends forever and forever and forever. So these arrows mean that this literally does not stop going ever at all. We draw the arrows though, so that we don't have to use multiple notebook pages to draw a simple line. So this is a line. A key difference though is that if you have a line segment, which is different from a line, the line segment ends. It does not keep going. Okay, so it stops here. It's not, this does not happen. It stops, it's done. Okay, line naming conventions, you can name it with a lowercase letter, so we could call this line N, or if we label a couple points on it, we can also call it line AD. So we can label it as N, lowercase n, or as line AD. So two options there, both work just as well. So first, a line is made up of points with no thickness or width. We draw it with an arrow at each end, so that's what makes it different from a line segment, is those arrows. It's named by the letter representing 2 points, or again, the lowercase script letter. So again, two options, two letters together, capitals for points or lowercase script letters. Points on the same line are said to be collinear. Okay, so A and D are collinear, and I'll write that there. A and D are collinear. Awesome. All right, let's keep going. Next one is plane. We define plane as a flat surface of points that extends in all directions. So the formation of a plane is almost like a line, right? We got all these points here, but then, oops, that's off. And then another one, and then another one, and then another one, and then another one. And it just keeps going like all over the place, all these points everywhere. So the idea for this actually is oftentimes you'll see it drawn, it's kind of like a parallelogram or sideways rectangle, if you want to think about it intuitively. And they're going to name it with like a capital letter. So we'll say capital C in cursive. That'd be plane C. An important thing to know, just like the line that we drew with the arrows, it keeps going. These also keep going. You don't have to draw these arrows in, but if it helps you think about it, it keeps going on forever and ever. So this dot right here is actually on plane C. Even though it's not directly on it, if plane C were to keep going, it works like that. It is like a piece of paper though, so it doesn't go in every single direction. It just keeps going up, down, left, right. So it doesn't extend out Like, it's not going to come out of your screen. It's just going to stay on the screen. So that's its plane. And your screen is actually a plane, an example of one. Second point to note here, if that's point A, and maybe this is point like F, points A and F are on the same plane, they are coplanar. So coplanar means multiple points on the same plane. So think about those co's, basically means just sharing, right? So we're going to be on the same plane. So a plane is a flat surface made up of points. Usually it's drawn as a shaded four-sided figure. So if we're going to like highlight this here, like when you see it on a textbook question or exam, something like that, usually there's some shading to it. So that's all that means. Next, named by a capital script letter. So notice how I made my C nice and fancy there. Just a capital script letter. That's what makes it different from a point. That's how you can tell the difference. So if you can, do your best to write that script. Best thing you can do is, if you're not sure if I'm going to know if it's script or not, you just write plain next to it. Also, if you'd rather, you can name it using 3 points. Okay, so if you have 3 coplanar points, they're all on that same plane. So if we have like A, D, and F, we can also call this plane ADF, because those are 3 points on the plane. So these are the 2 naming options. We can't just name it like plane AD, because that would be a line, right? There's only 2 points for that. And then again, that last note here before we go on, points that are on the same plane are called coplanar. All right. So those are the 3 definitions. Use it as a baseline. We're going to want to make sure that, again, they're definitions. So it's probably a good idea if we put those in our Google Sites. So just a reminder for you there. I'm going to go through some example problems now. Now, I'm not going to do all of these. I'm just going to do 1 or 2 for each example as a start. If you have any questions on these, I definitely recommend, and we're going to have a place where you can submit your answers to these questions. I would say reach out if you need it, but make sure that you also get these done. So first things first, use the figure to name each of the following. So a line that contains point P. So I see point P here, a line that contains it. You can have line N, and again, lowercase n, or we could have line something. 2 points that contain on that line work, so line PS. Okay, so that's an example of one that we can solve on there. Hint, hint, you might also help us out for question E. All right, so that's going to be an example from the first one. Next, from number 2, drawing some things. So point T lies on WR. I know that this has 2 letters, so this is going to be a line. So I'm going to draw a line. Draw more slowly. There we go. WR. And we know that point T is also on there, so we can put point T on there. To help you get started on B, plane Q. If you're not sure where to go, just start off by drawing that parallelogram and label it Q, and then draw whatever else it asks you after that. Example 3, I'm just going to talk about a little bit intuitively. We'll do A together, and then you'll have B, C, and D to answer on your own. How many planes are in this figure? So they drew 1, right? So we see that there is plane S, but that is not the only one. If you notice these kind of like dots here, those are showing depth for us. So that is like something coming out of an index card. It would be like 4D, right? You're looking at your screen, you're watching a movie, and then suddenly something comes out of that movie screen. So if S is your movie screen, point A and point D, those are shooting out of the movie screen in both directions. So actually that's going to represent a second plane. And we're going to see that all of these are connected here. So that is going to be, maybe we'll call that plane ABC. And it looks to me in this picture, because A and B are a part of this plane, that the line is on this plane. So because their line is on this plane, we're going to say that point D is also on that plane. So it's not going to represent a new plane. So we have 2 planes here. So we're going to say that 2. I don't know why my pen is writing weird like that, but 2 is the answer. Okay, so that's going to help you answer the next few questions. The last question here. Application, this is a bit of a challenge, so if you're not there 100%, that's okay, but I will ask, regardless of where you're at, please attempt an answer on this and please submit something. So lines A, B, and C are coplanar and lie in plane Q. Lines A and B intersect at point P, and line C intersects line B at point R, but does not intersect line A. And I just read it and I can't even process it. That's just way too much to even think about at once. So I'm going to break it down. All right, so lines A, B, and C. So I know that I need to draw 3 lines. Okay. So I have 3 lines to draw, A, B, and C. Okay. They're in plane Q. Okay, so I need to draw them here. Lines A and B cross at point P. So I'm going to say that these, they cross. And then line C intersects with line B. Okay, so B is going to cross both A and C. Okay, wonderful. But does not intersect with line A. So line B does not intersect at line A. So the reason why I wanted to go over this one is because of this right here. So if it does not intersect, there's only one situation in which that can possibly happen, and that is if we are parallel. So parallel lines are the only lines that don't intersect. If we had an example of, it's like, oh, these 2 lines, we'll call this line A and line B. If these are lines A and B, it's like, oh, Mr. Reardon, those don't intersect. Remember, these arrows mean it keeps going forever. So if we extend it, and I'll try to make that a little bit more straight. If we extend it, yes, it actually does intersect later on. The only time that we don't intersect is if we just keep going indefinitely, like next to each other. So this is the situation that Taylor Swift would name as never, ever, ever getting back together. A and B won't cross because they are parallel. But even if they're not parallel by just a little bit, they're eventually going to cross. Maybe it'll take 8 sheets of notebook paper to see the point where they exactly cross, but as long as they're not perfectly parallel, they will eventually cross. So that will be my hint to you. If we draw in line A and if we draw in line C, these are not allowed to intersect. They do not cross. Okay? Again, apologies, my stylus is getting a little bit messy here. I don't know what's happening, but hopefully that'll help. Okay? So parallel, we still have to draw line segment B. We still have to draw in a few points here as well. But hopefully this will be a good start for the application question for you. As always, any questions, let me know. I am here for you. Hopefully this is a good intro video to get us started thinking about these 3 definitions.